the design head, design engineering for substation, transmission line and EHVs cables. Right now, first I just have the introduction with your names and from which department or which is your branch. I think all people are from electrical, right? So that we will just have one your name, only name, and I think branch we already know. And what is your name?
Hello sir, I am Amrish Mahapatra. I am from Bhubaneswar, Odisha. I have completed my BTech in electrical engineering from IIT.
Okay. Your name?
Have you allotted any department in your?
No, sir.
Still, all are still freshers. No, this is not.
Okay. After induction, you will be going to O&M department, design department, and all. You will go different departments. Okay.
My name is Malcha. I'm from Odisha. I do BTech from CBIP.
You know, you have some people of MTech, some people of BTech, and now the today's agenda for the presentation will be substations, and you know AIS substation and GIS substation. What means the flow of presentation will be like now. You guys already know air insulated substation, gas insulated substation. I will be covering first AIS substation, air insulated substation, and then gas insulated substation. The flow of presentation will be like that. First, what will be the introduction? Then planning of the substation, how we will do the planning. Design and engineering, what are the elements are involved in design and engineering? What is it? How many types of the substations will be there? Various busbar schemes, what is applicable for 132 kV, what is applicable for 220 kV, 400 kV, 765 kV, depend upon their feasibility and the reliability. Other basis of substation equipments, primary equipment, secondary equipment and auxiliary equipments. Then engineering deliverables process chart flow, how engineering has to be done when the project has been come, what are our basic first process has to do. Sorry. Then single line diagram concept and objective. Protection SLD concept and objective. What are the clearances and insulation levels required for each substation? Bay width as far as the kV levels are concerned. Earthing and lighting. What is the purpose of that? Why illumination is required? Design calculation and layout engineering. Review of bought-out items, because vendor items are also there. You are buying transformers, you are buying CTs, PTs, isolator, breakers, so many items we are buying, right? So how we have to do the review of the bought-out items. Then detail of AIS and GIS concept. First, you know, if we talk about 10 to 15 years back, only air insulated substations are there. What is the need of GIS substation? Because why it is need, right? So now, why GIS and need an application? And then land requirement, what is the land requirement for GIS versus AIS? Then next part is GIS equipment, their functions, and 3D view of how the GIS looks from the internal view. Because CT, PT and other things, if you see at the field level, AIS substation, you have a very big CT. The moment if you will come to the GIS part, it is very compact and the size will be very narrow, right? That we will see in what will be the 3D picture, we will see it, right? And typical dimensions of GIS at 400 kV level. What is the GTP is a guaranteed technical particulars. What we will review, it will tell about each and every element, what will the fault will be there, what will be the voltage level will be there. Every element will be written in that particular GTP that we will cover in our coming slides. Then is the GIS design and safety requirements. What are the safety requirements? Erection, testing, commissioning of AIS and GIS and typical gas insulated substations. What is the substation now? Substation, whether it is an AIS and GIS, if you see, a substation is a part of electrical generation, transmission, distribution. Substation is not only the part of a distribution, right? Now, wherever generation is happening, suppose we have a generating plant where generation will be happening, that generation is happening, suppose we have a 500 megawatt generation plant, right? In that particular generation, you are having a TG, turbine generator, right? Generator will be giving you some voltage of up to 11 kV. So that 11 kV, we cannot transmit 11 kV because you are having if you transfer from one region to other, source to destination, you have more losses, because whenever the voltage will be high, the current will be low. And whenever the voltage will low, the current will be high, right? So that means the need of substation arises. The substation is a part of electrical generation, transmission, distribution system. Substation transform voltage from high to low and reverse, and transform any of the several internal important functions. In any substation, now what we are doing in substation, either we are doing stepping up or stepping down, right? We have the transformers with the help of somewhere wherever the discoms are coming, In that substation will be coming, there we have to do say 220 kV line will be coming, we have to step down because 33 kV system, Discom system starts from the 33 kV system. So 33 kV system, then after that again what they are doing stepping down to 415 level, so that the utilities, the consumers can be go. So there are different because you people are from the transmission line, I will be covering the transmission sector, and Discom I will cover some of the portion. So here we come to know in a substation transforms voltage from high to low and the reverse, and perform any other several other equipment. Electric power may flow from several substations between generating plant and consumers, and its voltage may change in several steps. Somewhere the substation will be coming up, sometimes transmission line having 400 kV, we have to step down the step down. A substation has a step-up transformer, increase the voltage while decreasing the current, where a step-down transformer decreases the voltage while increasing the current for domestic and commercial distribution. See, this is the one electrical network. Here we have a generation. Electricity is generating at various kind of power plant by utilities and independent power producers. So here generation is happening. Now generation is already done and users are sitting at this location and this location. So what we have to do here, with the help of this power will be flowing. Suppose this is this power will be at Odisha. This thermal plant will be Odisha, and we want to transmit this power from Odisha to northern grid. So how it will become? With the help of a transmission network. So this is a transmission network, it will be showing. Now in between maybe some of the industries are set up, some utilities say we need a power. So now this is, for example, I am giving you this 400 kV power will be coming from this stepping up this transformer is there. This is a substation. We are having 11 kV to 220 kV, and 220 kV power will be coming from this portion to this portion. And here we have reached to a substation portion. And substation, now we have utilities, Discom, some industry setup will be coming. So it at this particular region, now we have need has arrived for the putting a substation. So now what we have to do, because this industry need say 33 kV, and maybe this particular will be going to other substation which is 220 kV. So we have to see substation, the stepping up volt, because now 220 kV line will be coming, that we have put it 225 kV with 33 kV. They have setting up small industry substation where they will put 33 kV, 11 kV, and they arrange the utility. So with this substation we have different type of, we have 2 to 33 kV, and a line will be coming, line in and line out going, a line out will be going, because 220 kV coming and 220 kV going for other substation. So in particular region we step also down also depend upon the utility requirement, right? So this generation, and this is the domestic, because then Discom is coming, what it will be doing, because this load 33 kV by 11 kV, and then it will be giving for house domestic for 4 connection, 2 connection what using. If we have any question or anything in between, please raise hand and ask a question, because the moment you change the plan, you the question is only to understand, even you understand the slides, that is more important, right? Planning. Can you tell if as a man, if you will be in some your senior and ask, we want to put a substation. So what is come to your mind? What is your come to your mind? What would if some okay, your mind load your
after the capacity we will like and
equipments. Okay, from your side, any question, anything coming to your mind?
So which source it is coming and which destination it is coming?
Source and destination. Your mind?
In which place we will establish that?
Place where you have to establish it. Anything coming to your mind? Be open. There is no silly question, no right answer, not wrong answer.